Bismillahirrahmanirrahim. Students, in today's lecture, we will be able to learn the properties of waves, only diffraction. We will revise it again. We have already discussed it in previous lecture, but in today we will a little bit revise it, and we will do exercise. In exercise, we will focus on. In today's lecture, we will focus on the MCQs and conceptual questions. We will just. I will just give an introductory lecture on it. Okay, so first of all, we are going to revise the diffraction. As I already told you in the previous lecture, that diffraction is actually refers to whenever there is a bending of waves around the corners of an obstacle. Obstacle is रुकावट, ठीक है? So whenever there is bending of waves around an obstacle or around the corner of the obstacle, so that is actually diffraction. I then show you its image of diffraction in this picture. That diffraction, when there is a small gap, so there will be more diffraction, and when there is a large gap, so there will be low level of diffraction. And here is a general example of diffraction from our daily life, that the antenna rays are coming and it is diffracted from this obstacle. From obstacle, here is mountain, and then the diffracted signals then that reaches our home. Now we are going to discuss the exercise. So in exercise, the first thing which we are going to discuss is multiple choice questions. Okay, so one by one we will discuss it. The first one is, a transverse wave on a string has an amplitude A. एम्पलीट्यूड यू नो दैट द मैक्सिमम डिस्प्लेसमेंट, ठीक है? अगर आपके साथ पेंडुलम है 0 पॉइंट से वो मैक्सिमम डिस्प्लेसमेंट सपोज पॉइंट ए की तरफ जब हो जाता है, वो डिस्टेंस उसका क्या होता है? मैक्सिमम डिस्टेंस इज वो उसका एम्पलीट्यूड होता है. सो सपोज वो एम्पलीट्यूड जो है वो है ए, ठीक है? एंड अ टीनी स्पॉट ऑन द स्ट्रिंग इज़ कलर्ड रेड. सो एक टीनी स्पॉट रेड कलर का है जो कि स्ट्रिंग पर है. So and that is colored red. Okay, so what will happen if after completion of one cycle, so what will be the total distance covered by the red spot? So you know that what is one cycle? One cycle is that if a pendulum start moving from 0 to point A, then again to 0, then to the point B, and then again when it reaches to point 0, so that is its वन साइकिल. ओके, मीन्स के वो अपनी मीन पोजीशन से स्टार्ट होकर एक तरफ मैक्सिमम जाए, फिर वापस आए और फिर दूसरी साइड पर जाए और फिर वापस आए. सो दैट इज़ इट्स वन कंप्लीट साइकिल. मीन्स द कंप्लीट क्रस्ट एंड ट्रफ, दैट कंप्लीट इज़ द वन साइकिल. सो इन दिस अगर आप देखें तो 0 से जब ये ए की तरफ गया है, दैट इज़ ए. फिर जब वापस आया है, दैट इज़ 2a. फिर जब b की तरफ गया है, दैट इज़ 3a. और फिर जब वापस 0 की तरफ आए, सो दैट इज़ 4a. सो द करेक्ट ऑप्शन इज़ 4a. ठीक है, 4 टाइम्स वो उसने a एम्पलीट्यूड कवर किया है, एक तरफ जाने में दूसरी तरफ आने में. ठीक है. नाउ द सेकेंड MCQs इज़, विच ऑफ द फॉलोइंग डज नॉट अफेक्ट द पीरियड ऑफ द मास स्प्रिंग सिस्टम. ठीक है, आपको पता है कि टाइम पीरियड ऑफ द मास स्प्रिंग सिस्टम क्या है? T इजिकल्स टू 2π√m/k. ठीक है, ये आपके साथ फार्मूला है टाइम पीरियड का. पेज नंबर 7 पे आपकी बुक में ये फार्मूला गिवन है. तो इसमें अगर आप देख ले तो टाइम पीरियड जो है मास पे डिपेंड करता है, k पे डिपेंड करता है, एंड इट डज नॉट डिपेंड ऑन द एम्पलीट्यूड ऑफ वाइब्रेशन. ठीक है, सो इट मीन्स दैट इट विल what thing will not affect the time period? So the answer is amplitude of vibration. ठीक है, amplitude of vibration इसे affect नहीं करता, because in the formula there is no amplitude given, so it means that it does not depend on amplitude. Now the third one is, an object of mass m oscillates on the end of a spring. To double the period, replace the object with one of the mass. मीन्स दे आर आस्किंग कि आपके साथ एक मास स्प्रिंग सिस्टम है. इफ़ यू वॉन्ट टू डबल द टाइम पीरियड, सो विच मास शुड यू रिप्लेस. ठीक है, सो अगेन वही फार्मूला, दैट टाइम पीरियड इज इक्वल्स टू 2π√m/k. नाउ m is directly proportion to time period. It means अगर हम time period ज़्यादा करना चाहते हैं तो mass भी हम ज़्यादा करेंगे, ठीक है. So we will replace the mass by 4m. ठीक है. So this 4m is the correct option because other masses are values are less. So this one is the maximum mass. So by putting 4m we will get the double value of time period. Now fourth one, a car mounted on a shock absorbers is like a mass on a spring. If we ignore damping, how will the frequency of the oscillation change if the passenger or heavy load are added to the car? The frequency will means they are considering is as a mass spring system. ठीक है. मास स्प्रिंग सिस्टम में आपको पता है कि फ्रीक्वेंसी का फॉर्मूला क्या है, 1/2π√k/m. सो इन दिस द मास इज़ इन्वर्सली प्रोपोर्शन टू फ्रीक्वेंसी. ठीक है. इट मीन्स कि अगर मास हम ज़्यादा करेंगे तो फ्रीक्वेंसी क्या होगी, कम होगी, और अगर मास हम कम करेंगे तो फ्रीक्वेंसी क्या होगी, ज़्यादा होगी. सो इन दिस न्यूमेरिकल दे आर आस्किंग टू इंक्रीज द मास. ठीक है. सो व्हेन वी आर इंक्रीजिंग द मास or we are replacing it with a heavy load, so what will happen, the frequency will decrease. Okay, so the correct answer is decrease, option B. Now fifth one, if the pendulum completes exactly 12 cycle in 2 minutes, what is the frequency of the pendulum? ठीक है. In this numerical 2 minutes the time is given, and you know that minute we will convert it into second first. So 2 multiplied by 60, because 1 minute is equals to 60 second. So 2 multiplied by 60 we get 120 second, and you know that frequency is equals to 1 by time period. So 1 by 120 करेंगे, 120 जो कि टाइम है हमारे पास, 2 मल्टीप्लाई बाय 60 से जो आए. सो 1 by 120, so we will get option A, 0.1 hertz. Okay, hertz is the unit of frequency. Now sixth one, a certain pendulum has an iron bob. When the iron bob is replaced with a lead bob of the same size, its time period will. ठीक है. अगर आपके साथ you are having a pendulum, and in that pendulum the bob is iron bob, and if you replace the iron bob is with the lead bob, but दोनों का मास सेम है. ठीक है. दोनों के साइज सेम है. So what will be its effect on time period? So you know that time period depends on mass, but if the mass are same, so it means that the time period will remain the same. Okay, so option A, stay the same, is the correct option. Now number 7 is, a wave transports energy but not matter. We have already discussed it in the first lecture that it transfer energy but it does not transfer matter. Okay, now option A, the MCQs number 8 is, the bending of waves around the edges of an obstacle is diffraction. For this MCQs, I revised the diffraction topic in this lecture as well. Okay, so the correct option is diffraction, because there are bending of waves around the edge of the obstacle. Now in this slide, I just show you the formulas of time period and frequency. T is equals to 2 by √m by k. If you look at this formula, T is directly proportion to m, and frequency is inversely proportion to m. These two formulas we are using in the MCQs. Now here is the conceptual questions. Today we are not going to discuss it, but I just want that you all of you read it, you go through it, and try to find out its answer. And inshallah in the next lecture we will discuss each conceptual questions one by one, but slightly read it and try to find its answer, so you will be able to understand it more clearly. Okay, your assignment is that read conceptual questions as I already told, and revise your topic. Okay, practice each and every MCQs, and practice and memorize your topic. Thank you.